Hello everyone. I would like to share with you our experience in cherifying VxWorks and our Hypervisor, as well as to give a small update where we are today. So a couple of words, how did we start our journey? This slide is to show that of course we have tried building our system with in hybrid mode, but in practical usage of it, we saw that it helped us to improve our startup sequence, converted to the CHERI aligned way. But when we tried to estimate the effort needed to run, for example, user space in hybrid mode and kernel in pure capability mode, we found out that the effort is very similar in comparison with modifying everything to run in pure capability mode. The explanation, I guess, is very simple, because operating system is not just a library or application, but provides quite a lot of primitives for the whole systems. Because of that, it requires quite intensive modification and adding to the code specific hybrid annotations like __ capabilities and so on and so on. So we have moved directly to support pure capability mode in both user space and kernel, and yeah, this is where our system is today. This is the sources of information we used and hardware software tools we used. I have to add to this that with time, when we figured out that our problems probably very specific to our particular case, Slack community has helped us a lot, and we have found really a lot of support there from people participating in the Slack channels. I have to also mention that big source of approaches was CHERI. I know that work is ongoing there, and periodically we take a look there and find new parts which are important for us. For example, recently we were working on improvement of debugging facilities specific to VxWorks, and there we found also quite a lot of information, very useful information in current version of CHERI. So a couple of words about what exactly we were working on. So unfortunately, or not unfortunately, but this is, yeah, mainly due to historical reasons, our toolchain is not a standard toolchain, but has quite a lot of modifications, adaptations of intrinsics, and I do remember at some moment of time we migrated from GNU to LLVM, and it was really a long journey. So nowadays we decided, okay, right, we probably need to get closer to the standard LLVM, but still quite some work required to adapt. Not only toolchain itself, not only hooks inside it, but also our build system, which is pretty complex because we support really a lot of different platforms. It's not only ARM or PowerPC in the past or Intel, it's really a lot. And nowadays it's also RISC-V and quite a lot of small controllers. So the build system is really complex and requires really a lot of attention. So I have to admit that we still didn't succeed to fully automate it. We have spent almost 2 years working on it and still didn't succeed to fully automate our build system. There are still quite a lot of manual steps required. Then, of course, the changes inside the VxWorks and Hypervisor themselves, starting from startup sequence, board support packages, platform support layers. It's really quite a lot of work there. scheduler and exception interrupt handlers. I don't, looking, if I try to analyze the job we have done there, I wouldn't say that this job was really complex or somehow full of unclarities, but it was really a lot of routine work. So as soon as you get familiar with the ideology of CHERI, then the work is just running, it just goes further. So these are a couple of examples of the problems we have faced, and these problems, as I mentioned already, these problems were not really complex from the implementation perspective or from analysis debugging perspective, but it just need to be done, like the example below. This big copy is in VxWorks. Big copy we have really a lot of variants of big copy, because we support many different platforms and it is really optimized for all of them. Even for ARM, we have 6 or 7 versions of this big copy, and yeah, so probably from the assembler below you see the change is pretty trivial, but there are a lot of changes like this in the primitives like big copy. This slide I keep in my presentation because I'm really sorry, it's a broken slide. Looks like I made a mistake during the copy in a new template. The whole point here is that the compiler use different assembly instructions when trying to implement C-level atomic operation, So in Arm Morello it was used exclusive access pair. In Morello case it was a CAS instruction, and without instruction barrier before it was not really running, it was simply crashing. We have faced already a couple of problems like this, and again, it's important to mention here that it's not to say that the implementation is bad or compiler is wrong or something like that, but it's just to mention that the developer needs to be kind of ready to see issues like this and don't hesitate to pick up JTAG debugger and go inside. Right. Just to mention, we didn't really found the reason of this issue to exist, but as soon as we found workaround, we just moved further, we just skipped it. So probably investigation would be nice, but it's always a matter of budget available for such games. Yeah, this is a statistic, which from my perspective looks really nice because majority of the issues were resolved on compilation phase, addressing warnings produced by compiler or addressing, in some cases errors, in some cases warnings, but in general, majority of the issues were solved pretty straightforward way, and it has taken some time, but we were happy by the warnings produced by the compiler. That time when we done this job, it was LLVM 13, and now we are moving to LLVM 17, and I do believe that it might be even better now, even easier. So the solution for all these issues will really sit together and define the rules, which were also wrapped by macros, mandatory to use, and then the whole process became really simple. As soon as the rules are defined, the all operating systems and all libraries inside them are adjusted the same way, and the work is really kind of trivial. Except the cases, of course, as I mentioned before, when you face some crashes unexpected and JTAG debugger doesn't really explain why it or for example these big copies. This requires time, of course, but it's just less than % of changes, right? So from the conclusion slide, I would like to emphasize that, we have kernel and user space running in pure capability mode. Unfortunately, we cannot run one and hybrid one in pure capability mode. So whenever we try to use a new application or a new middleware or whatever else on top of the standard VxWorks, we need to really just convert it to pure capability mode. Make sure that usually it's just a matter of addressing warnings. So majority of middleware we have implemented in VxWorks requires just addressing warnings, and then 99% of the regression tests are passing. Everything works. There are, of course, quite a few ongoing things. First of all is VxWorks has really a lot of internal debugging facilities and internal debugging tools. And we have started from modifying shell to support CHERI. Even this job was pretty tough because in VxWorks shell allows to do really a lot. Really cast one type to another type and then modify them and so on and so on. So work on shell has taken quite some time. But in VxWorks there are also debug facilities like execution monitors and analysis, and this will require even more work, which is ongoing because JTAG is useful, but memory leak facilities and runtime analysis of the tasks and CPU loads and so on is really important for real-time operating system because it's nature. And of course vulnerability analysis. In VxWorks we keep and continue supporting the versions of the operating system 20 years old, you know, because once you deploy your operating system on a ship which in operation more than 50 years, in any moment of time customer can come to you and can, okay, right, so we would like to address this and these CVEs, you know, please help us. Because of that we keep bare metals of the bare metal versions of VxWorks, and then we supply patches to our customers. And you know, for us it's particularly interesting to test VxWorks, CHERI version of VxWorks, without applying CVE patches. That's what we are looking forward to do this. Yeah, this is all I wanted to share with you today. Any questions are very welcome.
Dmitry, can you summarize how really difficult this was to do? I know it was a challenging engineering part of the project, and there's potential like you could be doing another project similar to this.
Yeah.
Do you think it's going to be much easier for the second?
I would say so, yes. I would say so. This what I mentioned here, 4 engineers, you know. There were 2 engineers who doing testing and routine job, and 2 engineers who was really trying to understand how properly use CHERI and so on and so on. And majority of the effort was in the field to get a concept properly, you know, to understand really how to go further, how to make it scalable in the future and so on and so on. Because of that, and because of the rules we created for our domain in VxWorks and Hypervisor, we are sure that the same rules might be applied for any new platform. Right now we are looking forward to work on RISC-V because all this job was done from Morello, and our estimation of this job was really optimistic because we have faced almost no concerns which are really kind of, what we have to do there, we don't know. So I would say that moving to new platforms would be significantly easier than this job we have done before.
I wish you the best of luck again, that new contract.
Thank you very much.
Thank you very much. Yeah, it's really great to have commercial OSs as well, in addition to the open source ones. So thank you very much for your work.